Okay, this lesson here will be a video lesson that's going to combination of direct variation, inverse variation, line of best fit, curve of best fit to help prepare for the SOL. We'll get more into the depth of these things in class. All right, I want to talk about the concept of direct variation versus inverse variation. So basically, the way you figure this out, okay, is direct variation. If you divide y divided by x, for each one, you get the same number, okay? And that equation of y equals x, whatever that number is, just goes right in front of x. So like, let's look at this example. So if I divide 40 by 10, I get 4. If I divide 20 by 5, I get 4. So this is direct variation, okay? All right, that's how you know. Okay, for inverse variation, first of all, if you try doing 8 divided by 3, and 12 divided by 2. Notice how you don't get the same numbers, okay? Now what inverse variation is if you multiply x times y, you get the same number, all right? So look at this. So I got 3 times 8, 2 times 12. Notice how I get 24. So what I would do is it's just xy equals 24. So that same number just goes into that spot. That's how easy that is. So sometimes it might be easier to multiply them, and that way you know whether it's direct or inverse. All right, so let's go through some examples. Identify the variation and write the equation, okay? If you prefer the multiplication, it doesn't matter which one you try, okay? All right, if I do 3 times 15 and 9 times 45, not the same one, so it's not inverse. So let's divide 15 by 3 and 45 by 9. Yeah. So if you notice, okay, I get 5. So this is direct. Okay, and the equation be y equals 5x. Okay, let's look at this one. All right. I got 5 times 10, 25 times 2. Notice I get the same thing. So this is inverse variation. So this is going to be xy equals 50. Okay. All right. That's how simple those are. Okay. Let's look at this one. All right. Do 4 times 30. Okay. 24 times 5. Notice how when I multiply, I get the same thing. So xy equals 120. This is inverse variation. Okay? Let's try this one. 8 times negative 2. No, it's, as you can see, 100 times negative 25. Okay, obviously those aren't the same ones. So this is going to be direct. Okay? Now, let's figure out the number here. I do negative 2 divided by 8, negative 0.25. Negative 25 divided by 100, negative 0.25. So it's y equals negative 0.25x. Okay? That's simple. Direct, inverse, all that stuff. Okay? So what I'd like you guys to do is go ahead and just practice these two. Okay? Go ahead and unpause your video. All right? So this one, I checked is 6 times 10 is 60, and 20 times 3 is also 60. So I got xy equals 60. Clearly this is inverse variation, okay? This one would be 9 times 72, all right, that's 268, all right? So obviously that one doesn't work, so let's try doing division here. Okay, that's 8, and that's 8, so that's gonna be direct, and that's gonna be y equals 8x, okay? That's simple, all right? The same thing can be said for word problems, okay? Same thing can be said for word problems, all right? All right, I'm sort of simplifying the word problem just for the interest of time. Let's say it says cost is 60, profit is 300. So what I'm doing is looking at these. Cost is 150, profit is 120, okay? So once again, maybe the same deal. I'm gonna do 60 times 300, 18,000, and then 150 times 120, 18,000. So I can do cost profit equals 18,000. Boom. Automatic. Okay? Let's check hours and paycheck. So you can always assume this is X and this is Y if that makes it easier for you. All right, so I got 7 times 105. All right, 735. All right, 30 times 450. That's not the same. So let's try doing it the other way. 105 divided by 7 is 15. 450 divided by 30 is 115. So you can do it as y equals 15x. If you prefer to do it as p equals 15h, either one is fine with me, okay? All right, so it's the same concept, just with words, that's all, okay? All right, so what I'd like you to do is pause your video and go ahead and work on these two. Okay, all right, so this one, I got 48 times 8, or sorry, 8 times 48, 384. All right, so obviously these aren't the same, so let's go the other way. 48 divided by 8 is 6. 120 divided by 20 is 6. So this is going to be direct variation, okay? All right, I should have probably said back in those previous examples, this would be inverse, and this would be direct variation, okay? All right, so this is direct variation. This would be y equals, that's 6x. If you prefer to go, this is x and this is y, so this is cost and sandwiches, all right? Either answer for that, any of those would be fine, okay? Let's look at this one. I got speed times time is 720. Okay, let's do 40 times 18. Oh, whoops, 40 times 18 is also 720. So I got speed times time equals 720. If you prefer to x times y equals 720, this is inverse variation. Okay, so that's direct and inverse variation. All right, now I just want to go on to the concept of line of best fit and curve of best fit. Now, here's the big thing to understand with line of best fit. You're going to use Desmos, and I'm going to show you how to do that in a second. When you have a line of best fit, just write this down. You're going to do y1. You do this little curvy thing, which means approximately ax1 plus b. Okay? Write that down, because that's going to be vital. Okay? That's going to be vital. So that's what you do. We're trying to come up with the equation to almost like estimate the line of best fit. We'll do some more examples of this in class. All right? So what you do in Desmos is I hit the plus sign, and it will ask me to put a table in. And so I hit the table. Okay? And all I do is I put these values in. Okay? -3, and then 6. Okay? Then I just click down on the table, -2, and 9. All right? Then I got -1 and 15. Oops, that's not 15. Then I got 0 and 19. Okay, then I got 1 and 26. Okay, and then I got 2 and 33. Okay, as you can see, my dots sort of make a line. Okay, so that's the concept. All right. Now, to actually come up with that equation, what I do, and this is what I was just talking about, I hit y, and then I hit 1. Okay. Now, I'm going to hit the ABC button. You see this little curvy thing right here? That's my approximate symbol. Then A, and then I'm going to go x1, okay, plus B, okay? And what that does is it gives me these A's and B's, what my equation would be. So 5.42 and 20.71. So y equals 5.42x plus 20.71. Okay, so this is an approximate equation, all right, of the line, okay, of the line, all right. Let's do another one. Let's do this other one over here in Desmos, okay. All right, let's move this over, all right. I'm going to go ahead and delete my table and go ahead and delete that. So I do the plus sign, table, okay. So I'm going to put 0 and 5, 1 and 19, 2 and 31, 3 and 47, and then 4 and 61. And as you can see, same deal. You can see my dots make a line. So what I'm going to do is I'm going to go, I'm just going to work all over here. Y, okay, and then 1, okay. I'm going to go back to this ABC approximately, okay, A, all right, X, 1, okay, plus B. All right? And that's going to tell me what my equation is. So it's going to tell me that the number in front of X is 14 and the other number is 4.6. okay? And that's an approximate equation of a line, okay? So what I would like you guys to do, okay? I would like you to try to practice one on your own, okay? All right, and I'll walk you through it. All right, so go ahead and see if you can pause your video. Go ahead and see if you can get the answer. Okay. All right. So let's go ahead and make my table. Okay, I got -2 and 3. Okay, -1 and 11. 0 and 21. 2 and 40. 4 and 67. And 6 and 82. Just put whatever they got in there. As you can see, that's what your line looks like. All right. So what I want to do is y, 1. Okay. Hit this ABC, this little squiggle. Okay. All right. Then a, x1 plus b. Okay. And it tells me my equation of my line, and look, it even draws it out for me. That y equals 10x plus 25, or y equals 10x, 10.25x, plus 21.95. That's an equation, a line of best fit, and we'll get into more examples in class and how to apply it and all that kind of stuff. But for the interest of the SOL, just wanted to cover this, okay? Now, let's talk about this next thing that says quadratic curve of best fit. Okay, so here's what I would like you to write down. This is for the quadratic. All right, y1 approximate ax1 squared plus bx1 plus c. Okay, so go ahead and write that down. That's the most vital thing, is what does my equation look like, all right? And then why we have to do the ones is you see the table, it's pulling, basically telling the thing to pull from that table. Okay, all right, so let's go ahead and delete our table here, all right? And let's make our new one, all right? So I got 1 and 42, all right, 2 and 23, 3 and 16. Oops, that's 6. I'm going to zoom in a little bit here so you can see it a little better. All right, 3 and 16, sorry. 4 and 5. Okay, all right, 5 and 19. Okay, 6 and 31. Okay, 7 and 48. Now, this is not zoomed very well. You have to like sort of zoom in and change the table. We're not going to worry about that. Now, to find the quadratic one, all I got to do is y1 approximately a x1 squared plus b x1 plus c. Okay? And it sort of gives you the idea of the shape there. Okay? So what does this mean? This means that I would do y equals 3.86x squared, okay, minus 29.63x plus 67.42. And that would be my curve of best fit. Okay? So very similar to line, it's just, you gotta remember the other equation. Okay? And it looks like a quadratic. All right? Let's do another one together. All right? So I got a table here of 1 and 5, 2 and 13, 3 and 26, 4 and 15, and then 5 and 4. Okay? Now, since it said curve of best fit, I'm going to do y1, squiggle line, a, x1 squared plus b x1 plus c. Okay, it sort of gives me what the shape's gonna look like. So y equals negative 4.42 x squared plus 26.57x. And then the last number there is minus 18.4. Okay, so that's a approximation of the equation for the curve of best fit there. Okay, so what I'd like you guys to do is go ahead and pause your video and go ahead and find the curve of best fit. Okay, so let's do this together. Okay, let's go ahead and delete this, delete this. We're gonna go table, okay, 1 and 2, 2 and 11, 3 and 26, 4 and 41, 5 and 30, 6 and 14, and then 7 and 5. Doesn't look like much now, okay? But let's go ahead and put our equation part in. So I got y1, squiggly line, a x1 squared plus b x1 plus c. Okay? That gives me a good idea of what my equation is going to look like. So I got y equals negative 3.53 x squared plus 28.96x, okay, minus 26.71. Now, what's nice is, if they ever ask you to find values of the things, okay, you can just sort of scribble on this little thing that they've made for you, and you can find, if they said find x when it's 10, and you just go down, all right, or 9, let's say 9, and it would tell you your amount, okay? So you can just trace that, and that can help you come up with finding the other answer.